Hi everyone, in this video we are going to dive into how we can take the advantages of time series algorithm to predict the prices of the stock for next 7 or 30 days. So here is the problem statement. For whenever we do the stock trading, we had to read the chart reading. From the chart we have to draw a trend line, support and resistance. From that we had to make a decision that whether the stock can be purchased or not. I simplified this flow with the help of AI. I evaluated the model to do the stock prediction and converted those prediction into an actionable recommendation to the user. Okay, let's dive deep into architecture. First, for the UI, I went ahead with the Streamlit, and for the backend, I went with FastAPI, and for the time series algorithm, I chose three models. In the next slide, I will go through what are those. Okay, in the data pipeline, first I started the pipeline with the data collection and I did the data cleaning process. I applied 3 to 5 principles such as remove weekend, normalize closing price and drop NANs. After that, I built the model, I trained the model and generated the forecast, and for the UI, I converted those forecasting into actionable recommendation or suggestions. Okay, this is the time series modeling. First, I started with the stationarity check whether I can apply the data model or not. So I did the data pre-processing and evaluated the stationarity check with the ADF augmented Dickey Fuller test. And for the model fitting, I applied ARIMA model, Propert model, random forest model. After I built the model, I did the forecasting for the next 7 to 30 days and I evaluated the model performance with RMSE and I converted those numerical data into an actionable advice and sent back to the UI. That's the post processing steps I did. Okay, I evaluated the model performance with RMSE. Here you can see the ARIMA model that gives 1.8 and Propert model RMSE is 5.2, random forest is 2.0.0694. So here I chose ARIMA model only. The reason is that's having very less number of RMSE. Okay. For the project structure, I divided my code into two parts. One is for the backend, another one is for the front end. In the front end, I don't have much layer. I just all of my code written in the app.py file itself. For the backend, I have two pieces of code. One is for the time series, another one is for the fast API. In the fast API, I have two layer along with the api.py file. In the business codes, whatever the business logic I have written everything in the service layer itself. In the route layer, I just expose the API. In the app.py file, I just included that router. That's it. And for the time series, I have data, models, test, utils, main.py file. For better modularity, I did it in this way. Let me go the file one by one. First one is the data ladder.py file. So all these files can be executed with the help of main.py file that take care of the orchestration. We don't need to run this file individually. So this file take care of the data collection process. Next one is the preprocessor. Here I applied the stationarity check with ADF, and in the pre-processing I applied 5 techniques. One is the removing the weekend, lag one features, and rolling mean and min max scalar for the closing price, and drop all the NAN column. After that also I performed the stationarity check. Okay, and in the models folder I saved all the pickle files. Once the model is built, I stored the models into the pickle file. Okay. Okay, in the test model file I evaluated the model performance. Okay, so let me move on to the util file. So here in the evaluate.py file, I have the code for RMSE, and in the metrics, I have calculated the confidence code. That file resides here, and volatility, I have the whether the stock can be bought or not. That's what I'm predicting based on the deviation. Okay, the main.py file, let me walk through a bit. Okay, so the main.py file can be executed python space main.py. We don't need to execute the individual file. So as a first step, I get the input from the user, and once that I have the input, I loaded the I did the data collection with the load stack data, and I completed pre-processing technique, and I build ARIMA model, Propert model, and the random forest model. Once that model build process was completed, I evaluated the model performance with the RMSE. Okay, in the terminal section, you could see what was the result for the various models. Okay. Jumping on to the FastAPI part. So as I mentioned earlier, first I build the time series model, and I expose that model logic to the UI via FastAPI. So I have only one endpoint. That endpoint name is the forecast, and the ticker is the path variable. Here I have given name of the Apple stock, which is AAPL, and when I hit the send button, as per our design, it should fetch the detail from the FastAPI, sorry, open API, as well as from the time series model whatever I build. So it's giving back me all the detail whatever I wanted to display to the GUI. Okay, moving on to the fun part, the GUI part. So this is my GUI screen. This can be accessed only in my local host. So this is my local host URL. This time I would like to predict what's going to be the stock prediction for the Tesla. So here I have given the name of the ticker code for the Tesla, and I'm hitting on the get inside. So it behind the screen, it pulls the data from the open API through the fast API, and it pulls the data whatever we predicted in the time series model. Okay, along with that, it's showing the giving the information to the user whether the stock can be purchased or not. Here now it's alerting the user that it's in the downtrend, don't buy. So it's a high risk stock.